Hi students, this is a video on graphing square root functions, not using a table of values, but using a pattern. It's powerful because you're just taking the parent function, which would be y equals the square root of x, and you're translating it, you're sliding it around the coordinate plane, but it keeps its shape. If we look at the parent function, it does have a fixed and permanent shape, and it's based on the fact that when we take perfect numbers that are perfect squares, and we take the square root, we get bigger by 1 on the square root. So if I let, when x is 0, the square root of 0 is 0. When x is 1, the square root of 1 is 1. When x is 4, which is a perfect square, it has a square root of 2, etc. So if these are x's and y's, what happens is changes in y are vertical changes on the graph, right? You're changing against the y-axis. Changes in x are horizontal changes on the graph. The change in values here from perfect square to perfect square has a pattern. First, from 0 to 1, it goes up by 1. Then from 1 to 4, it goes up by 3. From 4 to 9, it goes up by 5. From 9 to 16, it goes up by 7. From 16 to 25, it goes up by 9, and so on. 1, 3, 5, 7, 9, 11, etc. So our horizontal changes, we slide left or right by a varying amount each time as we move from point to point on this, whereas we just make vertical changes of 1. So think of it like stairs. If I have a starting point and each time the rise in my stair is going to be 1. Okay, that's my vertical change. It's always going to be 1. But the first time my horizontal change is 1, I slide 1, I go up 1, and then the next time I go 3, right, like that, and then I go up 1, and then the next time I go 5, and I go up 1, and then this time I'm going to go 7, and so on. But if we look at these as points on the graph and connect them, we get the shape of the parent function of the square root function, which is just y is the square root of x. So what we're going to do is use that 1, 3, 5, 7 pattern, which we also used with parabolas, except we used that pattern worked vertically with a parabola to plot the points once we know our starting point. So we're going to look at this function, y equals the square root of x plus 6 plus 2. Notice that the a value is just an invisible 1. So we know that the starting point, hk, in this, because when I rewrite this in the subtractive format, y equals the square root of x minus negative 6, and then outside the radical plus 2, this means that my starting point is going to be at negative 6, positive 2. Okay, so I go left on from the origin, 6 to the left, and 2 up. And that's where this graph is going to start, at negative 6, 2. And then it's going to take on this pattern. From that point, if I'm on the graph itself, I can go up 1 and right by 1 for another point. Okay, up 1 and right by 1, or right by 1 and up 1. Then I'm going to slide 3 to the right and go up by 1. So 1, 2, 3 to the right and up by 1. And then I'm going to slide 5 to the right and up by 1. So 1, 2, 3, 4, 5 to the right and up by 1. So we get points like this that connect for, a nice kind of a smooth curve. And then when we're going to name the domain and the range, the domain is going to be always based on that negative 6. We can see that this never goes to the left of negative 6. The x values in the graph are always to the right of greater than or equal to negative 6. And it never goes below a positive 2. So the range, the y values on the graph, are going to be greater than or equal to positive 2. And We get those from here and we can look and see it on the graph. So that's it. That's how to graph using the 1, 3, 5, 7 pattern.